All right, welcome back. We are game 3004 in the winter 2021 semester at George Brown, and it's week 5, part 1 of our broadcast. I'm just going to switch over to YouTube for my video there. There we go. And this week, we're sitting at week 5. Last week, we did texturing and materials and so on, and we're supposed to do post-processing effects, color grading. I think it was a little bit overloaded in terms of what we did last week. So next iteration of this course, I'm going to rebalance stuff, like I said. So where are we in terms of our, because one of the things I like to do in this segment, which is our lecture segment, is talk about our project. You handed in your first playable last week, and next week is, by the end of the week, Sunday, your second playable will be due. And then following that, we'll have a project checkpoint, which is a class presentation. There will be no lab during that period, where you guys will come up and show everybody where you're at with your current release. And it's kind of in between your second playable and in the second half, your third playable. So it's kind of a middle step. A lot of times when we do this kind of thing in other classes, then people show just their second playable update. Some people just take their second playable and continue to work on it and then show me what they got there. So that's coming up in the next couple of weeks. And the project checkpoint, again, just to remind you, there are no exams in this course. You'll update, this will be taking the place of your midterm test or exam. All right, so that's what's coming up. What do we do? Last week, we talked about a couple things. We did materials in Blender. We did UV mapping, what that is. We made you download several textures and apply them to Blender. I did this IM GUI in Unity on the video. I also did the mini map. I started it on the video. I was going to do the inventory system. I'm going to try and get to that today. If not, I'm going to hit post-processing effects for sure. That's something we're going to do today. And we're going to try and build for WebGL again and deploy to GitHub pages, as well as I want to talk about the time of day system and NavMesh agents, AI agents, what those are, and how to set up a quick NavMesh. In the first lab, I was a little bit ambitious and created a randomly generated tile map. I'm not going to do that probably in the second lab, only because we have to bake our meshes programmatically. And as I was looking at the documentation to do so, I figured that it's going to be probably a whole other session altogether. I'll probably do a special thing with that. So I'm probably not going to do that. So let's move on to the next part of what we're doing. So next, again, project components due. So next week is your second playable release. I've started to look at your first playables recently. I've tried to mark everybody's weekly reports. They should be all done, as well as your peer reviews. There are a couple of people who are not performing. I'll be honest with you. I've seen some of the peer reviews, and most of them are great. You like each other. Everyone's doing their work, that kind of stuff. There are a couple that are not glowing, that basically say that this person or these people are doing nothing. Guys, if you're one of these people that are doing nothing, all that's going to happen is, remember, I'm using the peer reviews. If your team tells me that you're not performing or not pulling up your socks or whatever and doing your part, then your releases are going to be reflectant of your rating. Most of the time, like I said, 90% of the people that we have here in this class, now that you're in the final year and the final semester of your time at George Brown, you guys are all fine. I would say 95% of the people, maybe even higher, right? But there's always someone who is maybe not interested, or they have other priorities that they're following, and so on. And there's a couple of people like that right now that I'm getting reports on from their peer reviews, which are what they are. Some people also are not filling in your peer. If you don't fill in your peer review, guys, you get 0. You actually lose 1% of your final grade every time you don't do a peer review, which is, again, it's pretty insane. It's just a piece. It's like one document you got to fill out, in addition to your weekly report. Some people aren't even doing those. They're not doing the weekly reports. Weekly reports are worth 1% of your final grade every week. So that's like 10% of your grade. With your peer reviews and other things I'm getting you to do, it's worth 20% of your final grade pretty much for all that stuff. So it's a big hit you'll take if you don't do your weekly reports and you don't do your peer reviews. Those are individual pieces that you need to add in for yourself. So please don't forget to do them. Again, for weekly reports, I'm taking the best 10 out of 12, I think it is. And peer reviews, I think you need to do 4 out of 6. So I think that's kind of where we're going with all those. So please, if you haven't had a chance to do them, um, don't forget, it's a reflection on your personal mark, not a team mark. And when you do your peer reviews, it's individual. It's not a team effort. So next, again, your 4th weekly report is up and it's due this week. 5th weekly report is due next week. So make sure you hand those in. And then, like I said, 2nd playable release next week. So that's kind of an update on the project. But it looks like everyone handed something in, which is fantastic. I'm glad that every group is on board. Questions around the time frame and what we're doing from a project perspective, because that's one thing I want to hit during these times together in our lecture. How about this? How about does anyone want to talk about how things went? Does anyone have a negative experience, or how do you guys feel about your first playable? Did you accomplish what you wanted to? Was there something that you wanted to say that you couldn't get done? Is it too difficult? How are you feeling about it? And again, you don't have to come on the mic because we're recording, but you can definitely put it in chat if you want. Just a couple of thoughts. Yeah.
Hey, Alex.
Alex, how you doing?
I'm doing good. The only real struggle we had with the first playable was a couple of Git issues. Like everyone had their individual work done, but there was some issues merging the different branches and stuff together to get all of the different changes on one project together.
Okay.
But other than that, things went pretty smoothly. So I think for the next playable, we just have to give us some more time just to figure out those Git issues just in case they happen again, because we didn't really have we didn't account for that issue.
I recommend that you have a merge party. And again, it's not an official thing, but what we would do a lot of times is get together with, kind of the entire team, and then basically kind of merge everything together in kind of one little meeting. So it's kind of a managed merge, and then that would reduce the Git issues instead of everyone pushing to the same repository or something like that, where you clobber somebody else's work. You have a little merge party where you come together, share some files and those kind of things, and then you push everything together into one. It's a little bit more primitive than doing it the other way, but it can accomplish the same task, especially if you're new to Git and GitHub. So maybe something you want to consider.
Yeah, we eventually got it figured out. Just for the next time, just to have more time to, just in case those problems happen.
Okay, very good. Anyone else have any comments or anything they want to add to that discussion? Just like things about your project, how you felt your first playable release went, all those kind of things. Are you happy with it? Not happy? Okay. I'm going to continue then, if there's nothing else. Let's move into a couple of things I want to talk about today. So I asked you guys to make a mini map, and this is something that we've been making in the past. We did it last semester, and in the video that I produced last week, in addition, it was an addendum to everything we did physically in class because we were running out of time with all the things I asked you guys to do. I made a mini map that kind of looks around like this, except I didn't quite have a chance to complete it. We're going to do that today. Now the extra pieces here that you can add in and all that kind of stuff. Yeah, exactly. You can add in additional things, but one thing that you can see when it comes to a mini map is there's different, there are different pieces of or areas of interest that you can kind of denote with other markers. The player marker can be very simple, like a little square. You can use an arrow or some kind of triangle like I use. And the same thing with enemies. You can make them little squares. It really depends on your art style and your aesthetic, what you want to accomplish when it comes to the mini map. But this is really great because it gives the more information to the player in terms of what's up, what they have available, especially if it's a larger area like so. There's 2 ways to do a mini map. The one way that I'm showing you is actually a camera that looks down at the scene. And it's great for things like procedurally generated landscapes. Like if you're doing if you're, kind of doing that, the voxel game that we talked about, the survival, game that we're talking about. If you do that, then a minimap that actually kind of looks down because there is no set level, it makes sense then to use a real camera. The other way to do a minimap is to literally redraw your level in 2D and reposition your map, kind of superimpose your map on top of your real level. And what happens is when you're moving the player marker on your real level, then what happens is your mini map shows the relative position of your player marker on the 2D map that you've drawn. So that's another way of doing it as well. And what that does is it produces kind of something that looks like this. So it's kind of a top down view, but more controlled. So you can really stylize it. You can have your artist make it really, really nice and so on, or representative of the game world without actually being the game, right? So lots more control in terms of shadow, lighting, everything else you can do. So again, lots of ways of doing this. One thing I also want to talk about today is post-processing. And I was talking about to the guys, I modified my slides a little bit because we were talking about post-processing effects. And what I'm hearing is that for your OpenGL class, it's really, you kind of did an intro to graphics in that course. You didn't really do anything intermediate or advanced. I'm not sure. Do you guys have an advanced graphics course that you're doing here at George Brown, or no? Or is that it? Just OpenGL, like the first course? I think it's only one, if I'm not wrong. And if you're not doing intermediate graphics or advanced graphics, then you probably won't have a chance to do any post-processing effects. So what are post-processing effects anyway? Yeah, so then you may have not known what post-processing is. What is that? So really what you're doing is, the idea is for first you render the whole scene to a texture. So you have just like we did the minimap. The minimap kind of renders to a texture, not to the whole scene, right? So instead of doing just the minimap, we render the entire scene to a texture, right? And it's off screen, so an off-screen texture. And then what we do some processing off screen, some algorithms. Usually we use something called in OpenGL or even in Vulkan, some kind of frame buffer object is what we're using, right? Where we kind of store our information in terms of color, depth, and a bunch of other information, normals, everything else in separate buffers, let's say as an example, off screen. And what we do is we use additive blending to blend all those things together to produce a we render things to a full screen quad. All right, so the full screen quad will literally be taking the entire screen. So the effect looks like something like this. We bind to a multi-sampled frame buffer. Again, multi-sampling means you're going to get the color, the depth, stencil buffers, all those kind of things. And then you're going to render the game as normal. And then what you're going to do is you're going to blit the buffer to a normal frame buffer, a regular one, right? And then you're going to unbind frame buffers and you're going to produce it into a full screen quad. And the full screen quad is going to be the size, the width of your screen and the height of your screen. And that's what your screen is going to see, not the traditional way of rendering things that we normally see. So we're not using FBOs to directly render, right? We're actually doing things through a process, right? And this is happening every frame. So every frame, what's happening is you're redrawing everything, drawing things off screen, and then you're rendering things after the fact, hence post-process. Sometimes we also do things like ping pong texturing, where we have a texture that's actually being physically on the screen. And then what we do is we show that texture, we do some post-processing work on another frame buffer, and then we swap frame buffers. Similar to double buffering, but we're doing, we might have multiple buffers that we're using in terms of how we're, usually it's front and back, but a lot of times what we do is we use more than just two buffers. One of the things we can do with post-processing is something called color grading. And this is where the thing that I was doing with the class this morning. So let me just take a look here. So you have your original scene, and what you can do is you can apply different kinds of color correction, that's what they're calling it. And it's a kind of a film industry term where they kind of look at the scene itself, and then you can apply different warm tones or light tones. You can remove all color or even go grayscale, and to produce a different look and feel and an emotion is what you're really hoping for the scene. And again, this is done in a post-processing step, right? And the reason why you'd want to do this is because it can enhance the look and feel of things, like I said. A lot of post-processing that you can do, it's not just color grading. We're going to talk about other kinds of post-processing effects later this semester. One of them in more detail is going to be bloom, where you can actually take the bright parts of the scene and blur them. So you have a kind of separate the bright parts of the scene into its own texture. You blur those parts of the scene. So you have a blurred bright pass. And then from there, you additively blend everything together back into with the original texture, the full screen quad. You mix everything together so you have areas that are brighter in the scene are also blurry, and you create almost like a glow effect for those areas. That's bloom. And you can do all that with post-processing. Everything's done off screen, and then you render it to your full screen quad. Let's talk about color a little bit. And I want to talk about color because with post-processing in general and even color grading, and we'll talk about a little bit of color theory here. One of them is warm colors. Warm colors are made up of orange, reds, yellows, all those things. And just like it says, it makes you feel, it's an emotion thing, right? It makes, when you look at warmer colors, it makes you feel happy generally. Or it can reflect the time, the season a lot of times. For example, more fall colors would be things like the oranges, and more summer colors would be the reds and the yellows, right? Cool colors are like blues and greens and purples, light purples, and those are used for things like, to produce a brighter, bluer sky. It can also enhance things like a snowy effect, winter type effect, those kind of things. You can use blues, as well as things like nighttime scenes and that kind of stuff. So you can use colors, whether it's warm colors or cool colors, to change the tone of the scene for it to feel different. And why color grading? Because really you can enhance the atmosphere. I'm going to zoom in here to some of these things. And there's a great article that I've kind of attached to the scene. So you can see here, you've got your original scene. So same image, different colors, right? So here's the image that comes through. You see a little bit of God rays coming in this scene here as an example. And then if I want to enhance the reds, I can take a look at the reds and raise the red values of the scene. So again, this is a full screen texture is what we're doing. We're taking the original texture that from the scene and then color grading it or adjusting it, making a color adjustment to add reds, more of an ominous look, or you can add more blues to the scene, or same scene, or you can make it so that it's a sunny scene kind of in the afternoon maybe, or it's just a bright day, as an example. So there's like really cool stuff that you can do just by using a different color tone, or raising the tone, the value, all right, of an image. I can make it brighter, I can make it darker, I can saturate an image, I can desaturate an image, I can tint the whole image in different places, or increase the reds and decrease the greens. And this is a lot of times we do this in the film industry and in games to create an effect. All right, that's what we're doing it for. All right, and let's talk about the process a little bit in the back end. The process works like this. The first step is, in real life, if you're going to do it by hand and you weren't doing it with Unity, you would, actually even in Unity you can do this, you would create something called a 3D texture. So it's not just a 2D texture, but a 3D texture. And the 3D texture would have different color information. And you would use this thing as a lookup table or a LUT. Right? And what you're going to do with the lookup table is you're going to sample from different parts of the lookup table, to create the color gradient for your entire scene, right? Which is pretty cool. That's how it works at a very high level. So the first step is, let's get that 3D texture as a lookup table. And the way to do this would be going to something like a Photoshop or whatever. You take a screenshot of your game. As an example, let's say you take a screenshot of the current game, and then what you want to do is you want to sample the screenshot, and you come up with a cube file, a CUBE file, literally. And that cube file is something you can generate through Photoshop. Photoshop has the ability for you to create a LUT, a lookup table, 3D texture, right? And then once you have that 3D texture, you import it into whatever tool you want. And whether it's you use a LUT, you have a LUT loader in OpenGL or in DirectX, you can have one of those lookup table loader, or in Unity where you can look, kind of load it up. And then what you can do is you can use the information from that 3D texture to additively blend with your current scene, so it can affect each pixel almost like a 3D sample, texture sample is what you're doing. So how does it work? Basically what you're doing is, instead of using RGB values, you're using hue, saturation, and the value, so HSV, in terms of how the color works. So you can increasing the saturation. Think about what increasing saturation means. It means I'm taking the original color and I'm adding more pigment, right? So I have, let's say, a blue color, I add more blue, more blue, more blue. And so it becomes more, it saturates the scene with that blue color. If I desaturate the blue color, then, as I'm just looking blue as an example, then I remove blue pigment from the scene, remove by subtraction, subtracting blue as an example, until there's less blue in the scene. If I desaturate my scene completely, it becomes black and white or grayscale. That's what happens, right? So that's saturation. Value is like brightness or luminance, if you will. The more value, the higher the value, the brighter the colors, how much white I'm actually putting in the scene. So sometimes we say increase the color value, means just adding more white, making it like brighter, the actual color itself. If I decrease the value, it becomes black. That's what happens. The whole color changes from whatever the color is to black, right? And then the hue is on the color wheel. So I can change, the hue kind of goes in this counterclockwise direction. So where I clockwise direction, where I kind of go around the color wheel. I can increasing the hue or changing the hue moves a color from, let's say, blue into the purples, the reds, the yellows, and the greens, and back into the same area, right? And there's this axis of neutral colors, which is in the middle, because all colors have, if you notice on a color wheel, have that white area. Again, a little bit of color theory that I wanted to share with you, and understanding how hue and saturation works, because we're going to talk about it today when we talk about color grading a little bit. All right, so that is colors. All right. Let's talk about the post-processing stack that you're going to be using today in Unity, right? So I think it's great to use the post-processing stack, but we have to be careful in terms of what it can do for us, because remember, we're also going to be pushing this to from a full screen WebGL game, we're going to push it into a mobile game, right? So mobile games, they use OpenGL ES, so does WebGL. And so the range of color values and the way we do things, as an example, it can really degrade performance a lot if you don't do things properly. So here's as a good example of using the post-processing stack in Unity, and this is right from the Unity documentation. Here's the original screen sample up here, and then down here would be your processed sample. Again, it uses the same idea of a full screen quad. So imagine this is the screen. It takes this, renders it off screen, and adds different effects. So things that you can notice, if we zoom in here, again, it's right in your PowerPoint. So if you zoom into the original scene, I know it's kind of grainy to look at here, but if you notice, it's pretty flat. Like this area here where it says bar and so on, you can see that these are the bright areas of the scene, gas. This should be something like it's neon or whatever. You can't really tell. Everything looks kind of flat and washed out in a scene like this. But then if we add bloom as an example, you can see that the gas, the neon sign tends to glow more. And these glowy areas here, they tend to glow more. There's more of a glow over here. So the bright areas, this is a good example of where bloom is being used, right? Where the glowy, brighter areas are, should look like they're glowy and brighter, as opposed to flat like the original object, right? So it really enhances the look and feel of your scene. That's what it can do. And Unity has it built in. You don't have to worry about color buffers or frame buffer objects or any of that stuff. Unity will take care of all of it for you, right? So installation is pretty simple. You need to go through the package manager and add it to the, go to the Unity registry and then add it in. We'll talk about that during lab. And then what you're going to do is you're going to select two parts. There's actually two pieces you have to worry about. The first part is the layer. And the layer basically is you add a layer component to your camera. And once the layer component is added to the camera, then the camera itself, your main camera, whatever it is in the scene. By the way, you can also switch cameras, one that has the post-processing layer on it and the other one does not. A lot of times we combine this with something like Cinemachine, where if I want to show something that is blurred or whatever, I can I can disable one camera and enable another camera, virtual camera in Cinemachine, and all of a sudden I've got a different look and feel because that camera is connected to the post-processing stack layer. So it's going to render a full screen quad. The other one isn't, kind of thing. And depending on what kind of effect you want. So that's kind of the post-processing layer. That's the one thing. The other layer that you're going to need today is something called the process volume. A lot of times we put the post-processing volume on a game object like the game controller. And what the game controller allows us to do is you can select a post-processing profile. Again, it's another asset that we would create in Unity. And then what that would do with the post-processing profile is allow us to add things like color grading, bloom, depth of field, film grain, and a bunch of other things. All right, so that's what it does here. For us, we're going to worry about color grading today because it's going to help us with our day-night cycle, which is really what we want. So let's talk about time of day a little bit. So time of day systems is really what you're developing. When I say day-night cycle, that's what you're making. You're making a time of day system. A couple ways to get this done. And why is it done? It's done because you want to create a mechanic in the game. This is another mechanic type in the game that allows the players to make it almost like increase the level of immersion. They feel like they're going from one day to the other. Minecraft does this. Again, so does Terraria and other games like that. Actually, a lot of games have this, time of day. Even Cyberpunk 2077 has a time of day system as an example. So techniques for doing that, you keep a global time for the game where seconds be measured in real time or where an alternate time step is used. So, for example, a minute elapses for each second of real-time play, right? So, 60 seconds is an hour gone by. And then, 24 hours is in the day. This is a pretty fast time step. And you'll see that the sun in the scene would move fast, pretty fast. A lot of times it's not, a minute for every second. It's some other ratio of time, and you have to create that time ratio for yourself, whatever that's going to be, right? The other thing we do is we move the sun and the world in relation to the time of day. So in Unity, what we have is normally we have a procedurally generated sky map, a skybox. That's what we have right now. And a lot of times the skybox in Unity, we don't have a real sun. We have a representation of the sun based on the directional light in the scene, right? That's what's happening with the skybox in Unity. And as you change the direction of the directional light, so for example, if the directional light starts off with an angle of about 50 degrees, if you move the directional light so that it's from 90 degrees, so it's pointing right down at the scene, then what ends up happening is it looks like it's like noon, as an example. You can keep moving the directional light so it's at different angles, in the scene, so you can make the shadows go longer, just like it would in real life, and so on. And then finally, even sink below the horizon. And if it sinks below the horizon, it's really, really dark. At the same time you're doing that, you can add other lights programmatically. You can add things like ambient light in the scene. You can turn things on. You can add a moon, an actual moon object that is emissive, right? It could be a point light that goes across the scene, as an example, that casts shadows and does all those kind of things. And it can have a bluish color. You can also use color grading in combination with this to produce the right effect to make it feel like it's nighttime. Okay, that's what you want to do. And then you can also add or turn on some lights at nighttime at the same time that you're you're turning off others, right? So you can kind of have little particle effects that turn on at nighttime, like fireflies. Or, for example, you can turn on torches or outdoor lights or turn them off during the daytime. So you can make that transition from daytime to nighttime. And of course, we can do other things. The reason why we also want to do day-night cycle is because you want to, it could be a mechanic where we're warning the player, you better hide now because the enemies are coming out. They're going to come after you, kind of thing. So that's something that we can also use the day-night cycle for as a mechanic. And it's done a lot, okay, in games. So there's a couple of strategies in terms of how to do this. The other thing we're going to be talking about today is something called navigation and pathfinding. And when we did AI together, there's some things that we did by hand. We did A-star pathfinding when we were doing AI, and we talked about Dijkstra's algorithm, and we talked about different kinds of heuristics in order for you to do some pathfinding in the scene. One thing that we have with Unity is Unity has a built-in navigation mesh system that allows you to do, well, this is messed up, that allows you to do pathfinding and all those kind of things a little bit easier. Wow, I don't know what happened to my slide, but it is what it is. So we'll just fix it on the fly like this. There we go. So yeah, so what we have is, example is, here's your navigation mesh. What you do is you create a scene in the game. And then what you do is you bake something called a navigation mesh. We talked about it in AI, where it actually breaks down the surfaces of the game into regions. So I have a region here, I have another region over here, there's different regions, and then each of the regions are split further to create an actual 2D mesh that you can't see. It's invisible to the main camera, but it's something that's visible in the editor, right? And then what'll happen is your NavMesh agent, your enemy, as an example, will have a destination, for example, the player, and it will navigate across the scene, around the scene, across any surface that has a nav mesh baked onto it in order for it to find you. We'll talk about how to do that today, just as a beginning. You can also use something called off mesh links, where there's a link here and a link here, where you can have a nav mesh agent, when they approach a nav mesh off mesh link, to jump from one area to another area. You can do that. And you can also include things like nav mesh obstacles in the scene, where when you bake the mesh, and that's what's going to happen, then the mesh will actually bake outside of the obstacle. So you can do that. You can create areas where the nav mesh agent can't walk. Okay, that's something we're going to do in Unity today. So again, NavMesh, short for navigation mesh. Navigation mesh has been around for a long, long time. NavMesh agent, your autonomous AI agent that's going to be using. And one of the things I've asked you to do for your second playable release is give a little bit more smarts to your NavMesh agents, your autonomous agents. Increase the sensing suite capabilities of them. You can use tricks like we talked about last semester, line of sight and so on, and point of view. So you can do those kind of things, and it allows your AI in the scene to seem a little bit more intelligent, to detect the player, to come after the player, or to set themselves up as with some kind of ranged attack. They can come to a certain distance away from the player, and as soon as they stop, they can attack the player with a ranged attack. So lots of really cool stuff that you can do here. Or they can go right up to the player and attack the player with some kind of melee attack. Okay, so that's what the NavMesh agent and NavMesh in combination allow you to do. Off mesh link, we talked about what that is, and a NavMesh obstacle. This is all from the Unity documentation. When we want to build a NavMesh, there's a couple ways to do that. We can do things, in kind of an editor time, where we do it in, kind of off-screen time. We kind of bake the mesh like we talked about earlier, right? Or later on, there is a link that I gave you for baking the mesh or building the nav mesh programmatically, which is something that perhaps if you're doing a procedurally generated game, you want to do, right? Because each each piece of the NavMesh is something that you're going to you want to have your NavMesh agent connect with. Do you need to use a NavMesh for your any of the releases that we have here in the game? No, you do not. I'm not going to make you do any of this stuff. This is to help you. But there are a lot of little features that that give you some control or agents on a NavMesh. Some of them are things like agent radius, which we'll talk about today in lab. Agent height, how tall the agent is. Can they pass under an area or whatever? Maximum slope. So if I have some kind of ramp or something, what's the maximum slope that the agent will go up? What's the step height if they're going to go upstairs? What's the step height the maximum step height they can achieve from one link to the other? And again, here are the steps that you would have to make. Select the scene geometry. You're going to actually pull in a new window called the navigation window. And what you're going to do with the navigation window is you're going to check on navigation static, which is going to select the surface that you want. And then what you're going to do is you're going to bake the navigation mesh on your surface. Once you bake, it's baked. It's done. This is in editor time, right? Alternatively, you can do it programmatically, and I've given you a bit of a tutorial from Unity, which is extensive. It takes a little bit of time to do. They've got some great resources for this tutorial, and we'll cover something like this from a baked nav mesh later on this semester when I cover kind of procedurally generating your world kind of thing. How do we do that? Okay, so that's really what I wanted to cover today in lecture. Kind of some of the theory behind what we're doing today in lab, because we're going to really try and I'm going to fix up your mini map. And the next lab is going to start off very, very shortly. We're going to do that post-processing effect. We're going to include that in Unity. We're going to start the time of day system by thinking about what is our ratio of time that we're going to use. Is it going to be, 1 second in real time is a minute in game time or something like that? Like, what's the ratio? Is it 30 to 1, 60 to 1? How do you build a nav mesh, and how do I add agents to it? What's the kind of script that I have to use to get agents to follow you across the map, right? Example, the tiles that we kind of developed last week. And then we'll start our inventory system. One thing I haven't really talked about is how this is done. This should have been kind of started something like last week. Again, it's just a user interface that we want to create. And then when we need some textures to represent the items that we're picking up, almost like I want to create a texture that's going to display in the user interface. How do I create this inventory system? Well, I have these textures, and then what I'm going to do is I'm going to turn them on or turn them off, depending on if I'm going to pick up an item or drop an item, kind of thing. So we can, and again, there's different ways to do inventory systems for our games. Some people have asked me, like, do I need to make a Minecraft-like system? No, you don't. You can make it so that it's just a little strip, kind of at the bottom of your page or even at the side. And for things like tower defense games, a lot of times you see inventory on the side or at the top somewhere where it kind of shows how many resources you have that you've collected. As an example, it could be just numbers. So you see a symbol like iron, and then you see how much iron you're stacked into a particular slot of inventory. It could be as simple as that. But there needs to be some kind of user interface that tells the user how much of an item that they have. Some items will stack, other items won't. And a good example of that is in Minecraft. When we think about a system, and again, I'm just going to take a chance here before we end for the day. And for the next 5 minutes, I'm going to go to Minecraft. I know this is a really weird thing. I'm going to optimize here for video clip. So you're going to see this go away for a second. But let's do that for 1 sec. So I'm just going to go here into my screen, and I'm going to optimize for video clip just for a second, right? And I'm going to bring up Minecraft. And I want to talk about this as a study for a real game that's out there. Hopefully you guys can be able to see this. This is Minecraft, the Java edition, right? That I'm going to show you here. So I'm just going to play the game. And we're just going to use a new world. Doesn't matter. I'll just generate it, kind of where we're at, right? And let's see how we do this kind of thing. All right. Hopefully, I'm not turning sound on because there's no need for you guys to hear sounds for this thing. And hopefully you guys can see this. Yes? Can you guys see Minecraft? Hopefully you can. Awesome. So I'm just going to make a new world, which is what I want to do. So let's create a new world here in Minecraft. We'll just call this GAME3004, right, for our new world. We'll make it survival, and we'll make the difficulty hard. Why not? And we'll create the new world in Minecraft. So it'll generate it here. Again, this is using, it's very green. It's going to take a second, guys. You got to see what this is like. There we go. So you can see that we have an inventory system, and in Minecraft, right? And it's because there's a strip kind of at the bottom of the screen. We have a kind of a menu that comes up, and I'm using Minecraft as just an example of things that we want to do. That's our inventory system that we have in Minecraft. I don't expect you to have something like this, even for your game that's procedurally generated, right? You don't have to do that. When you say it's green again, do you mean that it's green as in like it's fully green, like it's cutting out? The problem with Zoom is the whole screen. Yeah, the problem with Zoom is that it's not great in terms of over the gameplay. I'm so sorry, guys. But if you look at maybe if you look at the YouTube video for a second. If you take a look at the YouTube video, so I've shared YouTube with you guys, then you'll see what this looks like, right, in YouTube, right? So, again, what's happening with Minecraft is you have this little interface at the bottom of the screen, and I can't show you it right now. Lauren says it looks good to you. That's good. So take a look at that YouTube stuff that I have. I have a YouTube link for you. You can see it. So that's the thing. So you have this, your little menu. I don't expect this. I don't expect a little menu that comes up that you pick up items. But in Minecraft, one thing is there's certain things that are stackable and certain things that aren't. So if I, punch the ground as a good example, then I can stack a lot of these items, right? Like dirt and so on, right? But there's going to be some items that are just not stackable. Like, for example, your weapons are not stackable in Minecraft, right? So it could be the same for you, in your scene. So notice I just run over the items. I don't have to literally select them or anything else like that, but you could make it so it's selectable. That's all I wanted to really talk about. I don't want to talk too much more about Minecraft because that's not what this game is about, or this day is about. But one thing to note is you need to think about some kind of system that allows you to hold your inventory. There's lots of ways to do it. As an example, it's just up to you how complex you want it. Does anyone have any other examples of? Patrick says, subscribe to my Minecraft channel. That's pretty awesome. Does anyone have any other examples of games that have an inventory system? Just that they like, as an example. Anybody? Animal Crossing, Fallout. I don't know if if I can do Fallout. Let's see what I've got in my library. So I might be able to do Fallout. Let's just see. I'm just going to pull over my library over here. Fallout is a lot different, and it's difficult for you to kind of do Fallout in. Maybe I can do it. I'm not sure how it's going to stream, guys, because Fallout is a full screen game. So if I lose you, bear with it. I'm going to try my best to see what happens. There's Fallout. So there's Fallout 4. Let's see if we can go into options, and I'm wondering if I can play this in a window. Yeah, there's windowed mode. Sure. Let's put a border on it so I can actually do something with it. And let's go from there. Let's see if it actually works. Again, this is me streaming on YouTube and as well as yeah. So much for if I can pull this window. It's pretty small. But it's okay. It might work for what we want to do anyway. Sure. I'll just use my controller for this one, just to make it easier. Yeah, so the inventory system in Fallout, of course, uses the Pip-Boy, right? So, and again, hopefully, can you guys see this one now or no? So we're kind of in this like desolate world. You know, as an example, I've got my companion with me, you know, as an example, and then I pull up my Pip-Boy, and that's the inventory system on the Pip-Boy. So there we go. We can see different things here, right, as an example. And you have different stats. Here's my inventory system where I have different kinds of weapons. I'm using the Fence Buster in this case. That's that's the kind of guy that I am. I like using the Fence Buster when I play the game, as an example. And I'm in power armor as well, so that you know, it allows me to see a different overlay that's outside of the world. So hopefully you'll be able to see that. We're in the dark, and again, one thing that they're using here is a spotlight. It's pretty simple. What they're doing here in terms of the way they're doing something. They're also using color grading, and in Fallout 4 for a PC, they also have, you can turn on things equivalent to HDR and all that kind of stuff. That's enough for Fallout. I wanted to show you this because we talked about Fallout. So Fallout definitely has an interface. Diablo 3, you guys mentioned Diablo 3. I know this is kind of a medley of stuff. Let's see if I can bring up battle.net, if I have that available. Let's see, maybe you guys will be able to see that. Okay, there we go. I'm just going to bring it off screen here for a second and see. I don't even know if I have Diablo on this. It's my don't. I'm sorry. But it's been a while. But anyways, yeah, so Diablo is another way of keeping your inventory and so on. One thing to look at is examples that exist, you know, as an example in different games. And the idea there is for you to try and take the best of what you see in some of the games you like. And so they try to bring them into the game world that you're using, right? So that's kind of an important thing to try and do. All right, I'm not going to go further than this. Again, going back to some reminders, we're sitting at, just as an end note, we're sitting at week 5. Next week, your second playable is due. If you notice in the details of your second playable, I'm asking for at least 50% of your game world to be developed at this point in your second playable. So make sure you, if you haven't had a chance to already, if you're not making a procedurally generated world, then you want to add more to your level, more details, more platforms, and those kind of things is what you want to add as you go forward, right? More enemies that are working and that kind of stuff. You want to iterate on the thing that you've already got in place. If you're someone who's procedurally generating their world, and I guess I'm thinking about Russ's team and Nabil's team, right? Then we can think about how you want to maybe do another pass in your game world to make it smoother in some areas, or you want to play with the chunks like you were talking about earlier, Russ, in your level to make it a little bit more customizable in terms of how it works and how the whole biome looks. You want to add different features of your game world is what you want to do. All right, so that's what's happening. That's coming up in your second playable next week. Next week, we'll be talking about destructible objects. And when we talk about destructible objects, we want to think about things like a health system, not just for yourself, but for objects in the game. Okay, so those are the things that we'll be talking about coming up next week. All right, any questions at all before we move on? I'm going to stop, kind of broadcasting this live. And then what we'll do is we'll take a short break and we'll start with the second lab, which I'm going to broadcast again, just like last week. Okay? So let's take a short break. I'm going to just stop streaming on YouTube and I'll see the people who are joining me for the second lab at 3 o'clock.